Hi, welcome back to Leetcode. So in this video, I'm going to discuss Leetcode problem 3754. Concatenate non-zero digits and multiply by sum 1. So you are given an integer n, form a new integer x by concatenating all the non-zero digits. Okay. uh, of n in their original order. Okay, if there are no non-zero digits, x is equal to 0. Okay, let sum be the sum of digits in x. Okay, return an integer representing the value of x into sum. Okay, got it. So for this example, let's see the first example. 1 0 2 0 3 3 4. Correct, this is I think the example number 1. 1 0 2 0 3 0 0 4. Okay, sorry, 3004. So this will be 004. Okay, so this is actually the input number. Now we have to generate a new number x which actually contain only the non-zero digits. Okay, so in original order. So first one, okay, this is non-zero. 0, this will not be part of this x. Next is 2, yes, this is non-zero, so it will be part of this. Next is 0, digit 0, so this will not be part of the x. Now go to next digit, next character 3. Okay, so this is actually non-zero, so this will be actually part of this x. Next is again 0, it will not be part. Next is again 0, this will not be added. Next is 4, yes, this is actually the x. Okay, and we have to calculate another variable, that is sum of this all the character present in this x. That means 1 plus 2 plus 3 plus 4. That actually 1 plus 2 3 plus 3 6 plus 4 10. So our answer will be x into sum. That means 1 2 3 4 into 10. That is actually 1 2 3 4 0. Got it? Let's see the output for this example one. Yes, 1 2 3 4 0. Okay, next suppose example, any another other example. Suppose input number is n is 1 2 3 5 5, then actually it is actually 0 0. Okay, so our x will be what, the from the input number n in the original order, the digits that are actually non-zero. So that means this one will be part of x, and 2 again it will be part of x. 3 5 5, correct. Next our sum of this is 1 plus 2 plus 3 plus 5 plus 5, and the sum of this is 1 plus 2 6, 6 plus 5 11, 11 plus 5 it is 16. So our answer will be x into sum. So here x is 1 2 3 5 5 into 16. So whatever actually the multiplication value, that will be our answer. Clear? So what actually we can do, we actually have some input number. We have some input number and check each character like digit by digit. Check digit by digit, correct. So if the current digit is non-zero, if it is non-zero, then it will be part of the x. So x will be added to suppose something, uh, whatever actually x is present plus the current character. Okay, and also our sum will be increased by x, sorry, current character. Correct, sum is the total sum of the all non-zero digit, correct. So we will actually check all the digit of the input number. If the current digit is suppose non-zero, then only we will create it. So our x is initially empty. This is our x. What is it? Non-zero. Okay. So x is initially empty. Now it is x is equal to whatever this current character is non-zero. So it will be part of this x. So it will be added to the this number x. And this actually maintaining the order also. We are maintaining the order also. They mentioned that the x, whatever the digit present in the x, this is actually the actual order in the input number also, correct. So that's why we are maintaining this order also. And next is the sum, because ultimately our answer will be x into sum, correct. So that's why at the same time we are doing the two things. One is the creating the new number x, and also we are actually storing the sum of the digit, correct. And ultimately after checking all the digits of the input number, we actually have two things. One is the x, and we we actually have the sum. So ultimately multiply this and return that. So what will be the time actually for that? So suppose let's see the what is the length of the input number 10 to the power 9. So 10 to the power 9 means maximum we can actually have digit length, maximum digit it can actually have 10, correct? So it will actually take big of 10, because I am actually I will check by character but digit by digit, so maximum 10 digit can be present, so that's why it will take actually big of 10 maximum, correct? Why it is clear? And for that this will be constant time big of 10. Let's see the code now. So we need actually one sum variable that initialized with 0, and we are converting this input number to the string, because then it will be easy to check digit by digit. So and also we actually have answer is the x, okay, and we will check the current character of the temp is the new string of in a string format of the input number. So I'm iterating from left to right. Let's see the example also in the left side. So this is our input number n, so I'll first convert this into a string and store this into the temp string, and now I am iterating from left to right. So first character it will be 1, so this is actually not 0, that means this will be part of our x. So that time here you can see that we actually just add this current character to the answer. So whatever the character we will get, that will be added into the end, correct? And also add this store the sum also. So sum will be added, will be increased by I minus 0. Why actually I minus 0? Because I will take the absolute difference, and this is current character is a character, so that's why I will take, suppose we actually have 1 minus 0 character difference, character of 1 minus character of 0, so I will get absolute difference as 1. So that value will be added to the sum variable. Got it? So after this for loop, we actually have the string answer, or actually I have actually this is actually x as a string format, and we have the total sum. If sum is still 0, that means what? We actually all the number actually is 0, or there is no number as a non-zero. You can also say either way also. So they mentioned if there is no non-zero digits, x is equal to 0. So x into sum, ultimately it will be 0 again. So that's why if sum is equal to still 0, then return 0. Clear? Else we have some digits in the x or in the answer string. So that time first of all convert this from string to number as a number. The and x here actually it is 1 2 3 4 for this example 1. X is or here actually answer string will be contain 1 2 3 4, and first of all convert this to the number, because I have to return as a number long. So that's why first of all convert this to as a long number from string to number, and then actually multiply with sum, whatever the sum actually is present, sum of all the digits present in the x. Got it? So this is simple, right? Okay, there is another second version of this same problem. This problem 3756, concatenate non-zero digits and multiply by sum 2. Okay, here's what is the difference. So in the first version of this problem, there actually will convert the whole string, whatever the input number is present, to the non-zero digits, like, right? But here actually the problem difference is that you are given a string s of length m consisting of digits. Okay, you are also given a 2D integer array queries, where queries I is equal to li to ri. Okay, so ith queries actually have two things, one is the li and another is the ri. So for each queries I extract the substring s of from li to index ri, then perform the following. So form a new integer x by concatenating all the non-zero digits from the substring in the original order. If there are no non-zero digits, x is equal to 0. Let sum be the sum of the digit x, and the answer will be x into sum. So the difference between the first problem and this problem is that here actually for each query I will try to convert that operation. That means we will have some substring means 0 to 7. Okay, suppose this is the 0 to 7. Suppose randomly I am choosing, and from this subarray I have to create a new x and the sum. And then actually we have to check what is the x into sum for that particular substring or the subarray. Got it? So you got the point, right? What is the difference between that problem and this problem? So suppose for this, so what actually brute force approach we can think to solve this problem at a first, that first of all, for each queries I will do the operation. First of all, create a new string for particular that character from 0 to 7. From 0 to 7 I'll iterate the input string s, okay, from 0 to 7, and then actually I will create a new string x, and then I will also calculate the sum. So for this example, suppose 102 10203004. Suppose I got L is equal to 0, R is equal to 7. Suppose. So our index is actually 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 4, 4, 8. Okay, 0 to 7. Okay. So suppose we got one query from 0 to 7. So what we'll do? We'll start from iterate. So I will take one x. Initially it will be empty, and we will take another variable sum. It is 0. Okay. So I'll start iterating from while I is equal to L and I less than equal to R, I plus plus. I'll start check that this is non-zero, current digit is non-zero, then actually add into the x plus whatever the character is present, and also add this into the sum. Okay. So for each query I will do this operation. So this will actually take big of n, because it makes it possible that I iterate the each character, correct? Each character from this start to end, 0 to n minus 1. Okay. But if there are q queries, if there are q number of queries, for each query I have to do this big of n. So this will q into n. Correct. Let's see this will work or not. How to verify that? Let's see the constant. So for this example, for this problem, the constant is that string length, it can go up to 10 to the 5. Okay. And number of queries is also 10 to the 5. That means total time velocity here actually it will be query is also 10 to the 5, and also length will be 10 to the 5. So it will actually 10 to the power 10, which is greater than 10 to the power 8. So it will not work. This approach will not work. But brute force approach is clear, right? If any doubt, you can comment on that. Okay. Now, how can actually optimize that, or how we can solve this problem in optimal way? So let's see. Suppose we actually have 10203004. Suppose this is actually the input number, but I want to calculate the ultimate x into sum of this particular this number, this subarray. Okay. Okay. So how can actually we pre-calculate all the values here? So what actually we need for this subarray? We need the x and the sum. Correct? Sum. And when actually our answer will be 0 if their sum is 0. Correct? And if we pre-calculate this, if we store this subarray value 0 to this I, if I store 0 to I, okay, what actually will store? If we store the sum and x, then can actually calculate this from L to R. Suppose 0 to R, I have stored these two things. One is the sum and one is the x. Okay, I can easily calculate this value, and we can store this also, that what is the sum from 0 to R, and what is actually the number from 0 to R, non-zero, by using only the non-zero digit. Okay, and now we want to calculate from L to R. So what actually we need? We need the sum of these digits here. So I can easily get this from here. So we actually have this thing, and now we want to calculate from here to here. Okay. So we actually have 0, L, and R. Okay. Now from 0 to R, I have the total sum of non-zero digit, and we have the x. Okay. Now we want to calculate from L to R the sum of all the non-zero digits. So how can I actually get that value? We can easily get from sum of 0 to r minus sum of 0 to l minus 1. Sorry, this is clear. From 0 to l minus 1, if I subtract this, we will get the sum of this l to r, because I have the total sum. I have the total sum from here to here, and if I subtract just from this point l minus 1, then actually I will get the sum of this zone. Correct? This is clear. So we can easily find out the sum of the digit between l to r, sum of non-zero digit between l to r. But how can actually we calculate the x from l to r? So we can actually see here that observation. Let's see. So we actually have suppose 1 2 3, and here actually from this is from 0 to l, okay, and from 0 to r we are saying suppose 1 2 3 4 5, okay. So we actually have these two things. We can actually easily find out the x of 0 to l minus 1, that actually 1 2 3, and from 0 to r we are saying that this actually 1 2 3 4 5, okay. The number is x number is 1 2 3 4 5, and so ultimately what is it actually between l to r, that actually 45. We can easily find out that. So how can actually we can actually get this? So we actually have 1 2 3 4 5, that actually is the x of 0 to r, correct, and we actually have 1 2 3, that actually x of 0 to l minus 1, correct. We actually have these two things. We can easily find out that. Now we want to calculate the x of l to r. Now we want to calculate that, right? So that is in the visualize we can actually do that this is ultimately 45. The x will be 45 between the l to r. So how can we actually get that? We'll get this by 1 2 3 4 5 minus 1 2 3 0 0, that will be ultimately 45. This is clear. So how are we getting the 45? So we know the total number is 1 2 3 4 5, and we have to subtract this number. So how are we going to multiply with this 100? Why 100? Because I know that in between we actually from between l to r we actually have two non-zero digit, that actually 4 and 5. That's why our number is now 1 2 3 4 5, and so that's why we have to count the number of non-zero digits also. We have to store that also value, correct, because we need that to multiply that how many actually between l to r, how many actually non-zero digit is actually present. So I have to multiply that 1 2 3 0 0, clear, and ultimately if we subtract it we will get the 45, that is the x between l to r. So what actually in the prefix array, what actually we have to store? This is clear. One is store the x between 0 to I, okay. Another is store sum between 0 to I. Another we have to store the non-zero digit between 0 to I, correct. We do store these three things, clear. Why actually we need these three things? This is also clear. I already explained. This x is required to know that from 0 to l minus 1, what is actually the number actually I have, and from 0 to r what is the number actually I have, and I know that 1 2 3 4 5, this is actually the x of r, and we know 1 2 3 from the x of l minus 1, and for that to know the x between l to r we need actually the non-zero count of non-zero digits between l to r. So that's why we have to store that also here, and sum to know to get the directly to what is the sum of the between non-zero digits between l to r, clear. So we need actually three prefix array. One is to store the x from 0 to I, one is the 0 to I sum of the digits, non-zero digits, and the count of non-zero digits between 0 to I, any number. So this is clear. So now go to the code. So first of find the input length size, that actually n s dot size, and they mention that if the number is large then return the modulo of 10 to the power 9 plus 7. So that's why I create a new variable of 10 to the power 9 plus 7, okay. And I need actually three prefix array. I already explained why 3 prefix array. One is to count the non-zero digits between 0 to I to know at a constant time. So it will be n plus 1 and initialize is 0. And prefix of digit sum. So that means non-zero digit sum between 0 to I to know at the constant time. And prefix number, the number we can generate from 0 to I by using the non-zero digits. Okay. And power of 10, this is not a prefix, this is actually to calculate, to multiply that easily, because ultimately you are seeing that here we have multiplied with 100, 1 2 3 multiplied with 100, like 20. So to know that how like 10 we have to multiply with 1 or 10 or 100, so otherwise we have to do that, right? 10 into 10 plus or plus that many times, so to do that constant time, so that's why we have pre-calculated that values. Okay. And initialize to the 1. So first of all, calculate the power of 10. That means at the index 1, if we have a 1, that means we have to multiply with 10. So that's a power of 10 of I minus 1 index into 10. Okay, next it will be, if it is index 2, that means we have to multiply with 20, right? 100. Got it? So in this, actually in the power 10 array, we have stored the multiplication value, we have to multiply. Okay. Now for the next, we have to populate a prefix array for this 3 prefix array. Prefix of the count, non-zero, and the digit sum and the number. So I'm iterating from left to right, so I'll get the current digit D. So if we have something, if we have some digit at the left side, so that means whatever the value actually I have, that will be anyways, that will be same, right? So at the index I, if I greater than 0, that means we have already seen some character at the left side, so whatever the value stored at the I minus 1, that will be copied to the current index I. Okay. Okay, 3 things I have copied: prefix of count non-zero, prefix of digit sum, and the prefix number. Okay. Now if the current digit is non-zero, then it will create a new number. Correct? That will create a new number, because this current digit will be part of the x, right? So that time we have to modify all these 3 things. So how is it to modify? Let's see. So number will be modified by which this will be actually, the current digit will be part of this. So previously, suppose we have seen only 1 2 3, now current digit is 4, so our array will have 1 2 3. So first of all, multiply with 10, then add 4, that will be 1 2 3 and 4. This is clear. So that's why whatever the current number I have, multiply with 10, then add the current digit. First of all, shift the all the digits to the left side by 1, so that's why multiply with 10, because the current digit will be part of a new digit, creating a new digit, right? So that's why shift, we have to actually create a new position for that. So that's why first of all, left shift the digits by 1. So that's why first of all, multiply whatever the current number actually I have, multiply with this with 10 and add this current digit D, whatever the value actually I have. It can be 3, it can be 4, it can be 5, anything, and take the modulo of that, because it can be large. And now this current digit is part of the x, so our sum will be increased by D, whatever the current digit actually value actually I have. So that's why in the current index I, the digit sum will also increased by D plus D. Okay. And now non-zero digit will be what? Count non-zero digit also will be increased by 1. So that's why it will be increased by plus plus, because I have seen this current digit D, right, at the index I. So that's why our count will also be increased by 1. This is counting only the non-zero, sorry, yes, non-zero digit, correct? So after this for loop, we actually have 3 things. We can easily find out that. So at the index I, what is the prefix number I can generate by using the non-zero digit? So, and what is the digit sum from 0 to I, digit sum of the non-zero digit, okay? And how many actually non-zero digit is present between 0 to I. At any index, I can easily find out that. Okay, clear? Now we have to return a vector of integer, that is answer. For each query, I have to find out what is the x into sum for each query. So that's why this will be, our answer type will be vector of integer, correct? Now I am actually iterating each queries. Okay, so for each query I'll get 2 things. One is L, left index, and the right index, Q0 and Q1. Okay, and non-zero will be what? So how many actual non-zero digit is present between L to R? So how can I easily find out that? So at the index R, I can easily find out that how many actually non-zero digits present between 0 to R. let's see another example by drawing. So 0 L and so this is R. So from 0 to R I can easily find out from this prefix array. At the index R, prefix count non-zero, index R. Now I want to calculate the L to R, right, between L to R. So this is prefix of R minus prefix of L minus 1. If I actually subtract this section, L minus 1, you can just solve L minus 1, not L, because L will be actually inclusive, right? This actually L and R actually inclusive. So that's why I have to subtract L minus 1. Got it? So I'm doing, just did that here, a prefix count of non-zero at the index R, and if L is equal, if L is greater than 0, that means we have some element at the left side. So that time actually we will subtract that value by L minus 1 index value. Got it? Either it will be 0 because there is no element at the left side. Clear? So if non-zero digit is equal to 0, that means there is no non-zero digit between L to R. Correct? This actually indicates that how many non-zero digit is present between L to R. So if it is 0, that means there is no non-zero digits. So that time store this into the answer vector 0. Answer dot pushback 0. Correct? And continue. Go to the next query. And if we have some query that actually have some non-zero digit, we have some non-zero digit. So that time we know the sum of this. We have to know the total sum of the digits, non-zero digits between L to R. So again, let's do the same thing. I know the sum of 0 to R by from this prefix array, prefix of digit sum at the index R, and subtract this is again L minus 1, right? If we have some element at the L minus 1, correct? This is we will get from the sum of the non-zero digits. Okay. Now we have two things already. How many non-zero digits is present in the L to R, and what is the sum of the non-zero digits between L to R? And now we have to know only this X, right? X. So X, to generate the X, what actually we need to do? First of all, I know the what is the number actually I can generate from 0 to R. Got it? Prefix number of R. And now we have to, so the again same thing, we know 1 2 3 4 5, and from 0 to L we know 1 2 3, and I know that here actually two non-zero digits is present. So that's why first of all subtract, multiply this with 100, 1 2 3 into 100, and subtract this. Got it? So that's why first of all this is the 1 2 3 4 5, correct? From this array prefix number of index R, I will get 1 2 3 4 5. Just map that values here. And now we have to know the 1 2 3, correct? 1 2 3. So how will we get this? I will get from the index L minus 1. So that's why if there is some element at the left side of L minus 1, so I'll get from the prefix number of array at the index L minus 1. Either else it will be 0. Clear? There is no element at the left side. Now we actually have two things. We know the 1 2 3 4 5 total number I can generate, and the number I can generate till L minus 1. Now what do we have to do? We have to subtract. We have to subtract what? 1 2 3 4 5 minus multiply with this 100. Then so whatever the number I will get that. So X is a 1 2 3 4 5 total number I can generate from 0 to R. And first of all, multiply this XL, the left number 1 2 3 with 100. So how you can decide that how with whom actually I have to multiply? Either it will multiply with 10 or 1 or 100 or 1000. So that will depend on the how many non-zero digits is present between L to R, right? So that's why multiply with the how many non-zero digits is present. Got it? And subtract this. Got it? And ultimately take the mod value. Okay. So this is X. Finally we have calculated X. We know the sum. Correct? Now we have to, what is the answer I have to store? That will be X into sum. So that's why I will just multiply with this sum. X into sum, and take the modulo of that and store this into the this out will store into the answer vector. Got it? And return answer. Clear? This is clear. So for this approach, what is the time history for that? So this for loop will run n times big of n, and this square will run q times whatever the number of time query is present, and all the operation here we are doing inside this for loop all actually constant big of 1. So ultimately time velocity will be big of n. Clear? N plus q, that will be better. Clear? I hope this is clear. If you have any doubt, any suggestion, you can comment on that. And if you like the explanation, please like the video, and if not, subscribe, please subscribe the channel. Thank you. Bye bye.